Hello, pre-algebra students. We're ready for section 7 of chapter 6, where we're going to talk about similar figures and continue using scale factor. In geometry in high school, you're going to learn about corresponding parts of similar figures. You're going to hear about that a lot. So we're going to do a little geometry introduction here and talk about similar figures. They are figures that have the same shape, but not necessarily are the same size. I like to compare my hand to my daughter's hand. They're the exact same shape, but obviously not the same size. They are in proportion to each other. So if you have two figures that are similar, then their corresponding angles have the same measurement, but the corresponding sides are not the same measurement, they are proportional. So we're still using what we know about proportions. Because corresponding sides are proportional, you're going to use the scale factor to find the measurement. So remember, here's where scale factor is going to come into play. What's the difference in scale and scale factor? I'm going to ask my second period class if anyone knows the difference between scale and scale factor. Yes, Chris?
The scale factor has the same unit of measure.
Scale factor has the same unit of measure. Good job, Chris. Thank you. So we have to make sure we're using the same unit of measure. Now take a big sigh of relief, everybody. Most of our geometry problems already have the same unit of measure. Yes, we do not have to do unit conversions. Yay! Okay. So let's look at the example problem that has worked for you in your notes. They have told us that they are similar. So if they're similar, we already know they are in proportion. So we can look for corresponding sides. So the base of this trapezoid corresponds with the base of the bigger trapezoid. And then here's a side that's going to correspond with a side. Oh, there's our x. So they said 12, the little base, is to the big base, as the little side is to the big side. And that's how you're going to set up a proportion right here, and you're going to cross multiply to solve for x. So let's look at number 1 that has not already worked for us. They tell us that they are similar, so I don't even have to check to see. You can say, I'll save that for your sophomore geometry teachers to make you check to see. Alright, so if they're similar, 5 is going to correspond with 10 and 7 is going to correspond with x. So I can set up a proportion. 5 is to 10 as 7 is to x. And now I'm ready to cross multiply. 5 times x equals 7 times 10, which is 70. Anybody know what 70 divided by 5 equals? Braden? Okay, good job, Braden. Next, we have two similar pentagons, and we know that they're similar because our instructions told us so. So the base of the pentagon here, the 22, corresponds with the base of the big pentagon. Now, I could say 22 is to 17, and stay within my little pentagon, but if 22 is going to be compared to 17, for my big pentagon, I have to compare x with what? Does anybody know what goes in the next blank? Hannah, what do you think goes in this place?
51.
51 from the big pentagon. Now, if you still want to say 22 is to x as 17 is to 51, we'll both get the right answer. So when we cross multiply, 17 gets multiplied times x. And 22, I don't know what 22 times 51 is. Can somebody with their calculator help me out? All right, Bronzy.
1122.
1122. And now I divide by 17. So when I divide, Sarah, what do I get? 66. Now, let's go back. We're doing geometry, so what should I put along with 66? Meters. And I failed to do that with the first problem, so let me fix that mistake. That was also meters. So in geometry, we need to know what our unit of measure is. All right, I think y'all have got the hang of this. I'm going to leave 3 and 4 for you to do on your own. And my daughter told me a Thanksgiving joke last night. If a turkey had a cell phone, what would its ringtone sound like? Anybody know?
Wing, wing.
Okay, sorry for that really bad joke, but I just had a student ask a very good question. Please realize that there are six correct proportions that you can do with these problems. 6 of them, and they're all correct. So for number 3, I can say 3 is to 15, which is probably the one I tend to use the most, as 7 is to x. Or I could say 3 is to 7 as 15 is to x. Or I could say 7 is to 3 as x is to 15. Or I could say, what am I missing here? 7, let's see, 15 is to x. Okay, 15 is to x as 3 is to 7. X over 15 equals 7 over 3. And there's got to be one more that I'm missing. I think it's 15 is to 3 as x is to 7. All of these, when you apply cross multiplication for any one of these, go through and multiply each one of them. 3 is being multiplied times x, 3 times x, and 7 is being multiplied times 15. So your the result of cross multiplication for all 6 of those is 3x equals 7 times 15. So that's going to be what you'll use to solve. So there are 6 correct proportions, and not one of them is better than the other. Okay? Thanks for staying tuned this long, and have a great day.